Yeah, very good evening to all of you, beta. We have started with what where we are going to start today with a new chapter, that is chemical kinetics. Now, beta, whenever I talk about chemical, means it is related to what? Chemical reaction. It is related to what? Chemical kinetics means what, beta? Speed. In chemistry, instead of speed, what word we are going to use? Rate. So in this chapter, what we are going to study about? Rate of chemical reaction. Instead of speed, what word I am going to use? Rate. So we are, in this chapter, what we are going to study about rate of chemical reaction and factors affecting the rate of chemical reaction. Chalo beta, now I'm giving you two example, beta. I'm carrying one reaction at low temperature and one at high temperature. Which one will be faster? Yeah, बोलो बेटा, एक ही के नहीं साजा दिख नहीं रहे इस समय. Little bit on this shift, man. हाँ बस बस बस. Okay, I gave you the notes ना बेटा, तो बताओ it is on high temperature. Clear? But here also condition is applied. There are two types of reaction. The reaction one is exothermic and one is endothermic. So who will favor at high temperature? Endothermic. But exothermic होगा तो it will be favored at low temperature. Clear? Okay. Then beta, I am taking two container in which there is dilute acid and another one it is what beta? Concentrated. मैंने record किया ना हाँ. अच्छा तो who, and in both I am adding a piece of metal. Who will react faster, dilute or concentrated? So rate of reaction is directly proportional to concentration. Now for gaseous reaction beta, in gases beta, I have taken two containers. Okay, in one the pressure is less, in another the pressure is more. So in which case molecules will come closer to each other, less pressure or more pressure. So more pressure hoga, तो beta collision will be what? Faster, and therefore reaction will be faster. So for gaseous reaction, rate of reaction is directly proportional to pressure. Now I just want to know, Chanel, Ryan, and Melroy, your notes. Today I have given these notes, so you have to come for the class first. So to whom should I give your notes? Acha, you will come on Monday, na beta? ठीक है, चलो, anyways. It's directly proportional. And rate, what were we doing? हाँ, yeah. I have taken a big piece of sugar, 10 gram का इतना बड़ा piece है sugar का, and the same 10 gram I made powder. Who will react faster? The big piece of 10 gram or the powder of 10 gram? Both quantity has to be same, beta. So powder, why? Because whenever you take powder, surface area increases. Suppose if I'm giving this, suppose this is 10 gram carbon reactant. Okay. So surface area is available this, and this. But if I cut it, it is 10 gram only, but I'm cutting it. So can you see two new faces are coming in front of you? So surface area increases. Therefore, rate of reaction increases. Is this clear? Okay. Acha, so rate of reaction is directly proportional to surface area and inversely proportional to size. Big piece if you take beta 10 gram and small pieces of 10 gram. So who will react faster? Small pieces. So rate of reaction is inversely proportional to size. Then beta, sometimes beta reaction, what does catalyst does? It either increases the rate of reaction or decreases. If it increases, we call it as positive catalyst. And if it decreases, we call it as negative catalyst. Then we have intensity of light. What do you mean intensity of light is which reaction beta? Photochemical reaction. Right? So in photochemical reaction, if I increase the intensity of the reaction will take place in presence of intensity of light. So if I increase the intensity, reaction will be faster. Now this is very, very important. This you have to remember. For each degree rise in temperature, rate of reaction becomes what? Double. Rate of reaction becomes. So this way, what type of question they will ask? Suppose beta, I have given one reaction. Okay. Initially it was at beta 10 degrees. It was at, I am raising the temperature to 50 degree. So 10 to 20, 20 to 30, 32 and 42. Acha. If what we have studied for each degree rise, the rate becomes double. Me at suppose at 10 degree if it is R, then at 20 degree it will become double. So it will become what? 2R. So here again it will become double. So how much it will become? Here it will become, and here it will become 6. कैसे झिंगी 4 का डबल कितना होता है? 8 ना? 8 का double is how much? So rate of reaction will become how much beta? Acha, now tell me beta, how many arrows were there here? If it's how many intervals were there? 1, 2, 3, 4. So basically it becomes 2 raised to n times. 2 raised to 4. 2 raised to 4 is how much beta? Suppose Nerissa, if I tell you, if I increase this reaction instead of 10, I would have given you how much beta? If I would have told you if I increase the temperature from 0 to 50 degree, then so how many arrows you will get? Tell me. So here how much was my rate? R. So it become double now, beta. So how many arrows are there total now? Count. 1, right, beta? 2, 3, 4, and 5. So it will be 2 raised to 5. So it will become how many times? 32 times. Is this clear to all of you? So this is all about your rate of reaction. अरे वो शोभित अच्छा चला अच्छा now अच्छा this was all about the speed. Now beta this is very important part. The main part is going we are going to start. Now suppose I am carrying out a reaction. Now I am carrying out a reaction in a big container. Look here. It is a transparent container. It is what? Transparent container. I am taking 10 gram of zinc. 10 gram of zinc. So initial concentration. Now in this entire chapter, beta, whenever we are going to write reactant and product, reactant and so for reactant, what we are going to use symbol A. What symbol we are going to use? A. And for product, what we are going to use? B. Right? Achha, whenever I say concentration, concentration means what? Concentration. So concentration, we write square bracket. Okay? So if I say concentration of reactant, so it will be what? Concentration of A. Concentration of product, then it will be what, beta? Concentration of B. Is this clear? Okay? Chalo. अच्छा जल्दी जल्दी बैठ ऐसा क्या यहाँ पे एक्शन रिप्ले क्या कर रहा है ये तेरा पेपर मिला ना अनवी तुझे इसको मैंने दिया था उसे Now please pay attention. I have taken a big container. In that I am taking a big piece of zinc element. Zinc. How much it is? 10 gram. How much it is? So initial concentration. Whenever I write square bracket means what it is? Concentration. For reactant, what you are going to use symbol A. So how much I have taken beta? 10 grams. So A1 means initial concentration was how much beta? 10 gram. I am making it react. I'm going to make it react with HCl. So what I'm going to get? Zinc chloride and what will be evolved? Hydrogen. Now how you will come to know that the reaction has started? I have given this whole transparent container. In that I have added zinc and HCl. How will you come to know that the reaction has started? Array, we will see effervescence of hydrogen or not. Right? Acha. Initially, beta, for reactant side, what I told you, what we are going to use. What is the symbol for initial we are going to use? Concentration of B1. So initially, if reaction is not started, when time is initial time, if I'm going to take this time one is 0. So when time is not started, okay, initial time is T1 and final here also initial time will be what T1. When reaction has not started, you will see any bubbles of hydrogen? So how many bubbles you will see? 0. Now, suppose I'm carrying out this reaction for 10 minutes. So what will happen after 10 minutes? Final temperature is how much beta? Final time is how much beta? 10. So after 10 minutes, what will happen to the size of this zinc? Will it increase or decrease? Zinc is reacting with HCl. So what will happen to its size? Decrease, na? Decrease. What you said? Achha, decrease or not? It will decrease, na? So it has become this much zinc. So it has become, let us say, how much beta? 2 grams. So what is my final concentration? 82 means this is all my initial thing. And this is what beta? Final. This is what? Final. Achha, initially, how many bubbles were there before, when time was 0? Now, let us say, I will save some vague value. How much bubble I got, let us say, after 10 minutes, T2, after 10. Let us say, I got how many bubbles? 50 bubbles. So now you tell me, beta, during the course of reaction, what happens to reactant? Reactant ka size bada ya kam hoga? Tell me, will it increase or decrease? And product, it increases or decreases? So during the course of reaction, concentration of reactant will be less and will go on decreasing. And for product, it will go on increasing. Any difficulty till here? Okay, but now I carried out this reaction. I want to find the speed. Speed means what in chemistry? What word we are going to use? Rate of reaction. I want to find what? So for rate, what is the formula? Rate we write, for the rate we write final minus initial. Final minus initial upon time interval. Time interval means we also what? Final time minus initial. Don't write anything. First pay attention here. Okay. Clear? Now I'm going to write this in two forms. One is for reactant and one is for this side was what? Zinc and HCl was what? My reactant or not? This is what? Product or not? Tell me. Okay. Now initial, so rate what is the symbol R? How much was my initial concentration here? Final is how much beta? A2 or not? Tell me. So I'll write A2. What was my initial? A1. And what was my time interval? T2. And here it was T1. So T2 minus T1. So for in terms of product, if I write then product, what was what was B1 and this was my final B2. So what I'll write? Arush beta, what I'll write? B2 minus B1 upon T2 minus. Okay. Here, acha, in maths we have studied na x2 minus x1, we write delta x. Okay, but so when A2 minus A1, what I'll write beta? Delta A. What I'll write? And this will become delta T. Yeah, but beta, when I write delta A, I get, what? I get minus. Oh my God. Why I will get minus? Think and tell me. No, are for reactant side. A2 minus A1. You only see the values and think. So what answer I'll get? 2 minus 10 or not? Tell me. Sorry. 2 minus. So here, beta, can you see this was 2 and this is how much, beta? 10. So therefore we get negative. But can speed be negative? No. So what does the negative sign indicate? As time increases, concentration of reactant decreases. Rate can never be negative. Are you getting? But why we got minus sign? Have you all understood? Clear? Okay. For product, when I do what I'll get? Delta B by delta T. But here I will not get negative sign. But here I get positive. Why? Because my final was 50. Initial was 0. So what does this indicate? As time increases, concentration of product increases. And for reactant rate, so if I want to define rate of reaction, how will I define? Rate of reaction is nothing but decrease in concentration of reactant per unit time or increase in concentration of product per unit time. Are you getting it? Chalo beta. Now what I want all of you to do, look, pay attention here. In my notes, so I want all of you to come here quickly. Look, beta. What is rate? Look, I have written here everything. Can you see these notes? So students who are attending online, your notes are with me. Next class, you have to come. Huh? And Ryan, I'm not going to allow you. And Chanel, both of you.
Yes, sir.
Okay, A2 minus A1. Can you see this, beta? This is in terms of reactant. And this was what? Product. So reactant, why I got minus sign? Have you understood? If I negative sign that, what happens? Concentration. For reactant, as time increases, concentration of reactant decreases. And for product, what I got? Tell me. Can you see? For product, what I got? Delta B by delta T. Are you getting it? What happened? Tell me, Keegan. Yeah. Now, so hey, what does the negative sign indicate for reactant? Negative sign indicates what? As time increases, concentration of reactant decreases. And for product, what it indicates? Product increase. Now, if I want to plot a graph of both reactant versus product, tell me, hey, this is for reactant and this is for product. So here what I have written, reactant के लिए क्या लिखे थे? Concentration of A. This is my time. For product, what we used to write here? Concentration of B. And this is what? Time. A. What happens to the concentration of reactant with respect to time? It will go on decreasing or not? Tell me. अरे time increases, reactant देखना कम हो रहा है कि नहीं? अच्छा, product में what will happen, beta? For product, it will increase. But when time is 0, how much was my product? 0. Then beta, it will increase. And then it will remain constant. Why it will remain constant? Equilibrium नहीं बेटा. If reactant will get over, तो no more product can be formed ना बेटा. So it will remain constant. बराबर है. अगर reactant खत्म हो गया तो फिर product constant ही रहेगा ना बेटा, right? Clear है? अच्छा, MCQ में ना बेटा they can ask this, they ask this graph. So this was what beta? Reactants, beta, concentration of reactant, and this was, don't draw anything, everything is given. This is your product. As time will increase, beta, your concentration of this graph will remain what? Constant. Here it is going on decreasing. Now what I can give you in exam, beta? I'll give you this question only. Look, I can change this. How, I'll give you product and time. This I'll write and I'll mix them up. I'll give you this. So I'll write, this is X, this is Y, then I'll write something like this. This is my Z. Out of this, which one is correct for product? Product versus time. Which one is correct? X, Y, or Z? Have you understood this? Chalo. So this was all about this thing. Reactant and... So this was what? Rate of reaction. So we have done rate of reaction. Have you understood this graph also? Hello? If this is light, then please make it dark. This is concentration of B and this is concentration of A. In your notes, it is visible properly. Hello. So what was rate of reaction? Mega rate of reaction for in terms of it is decrease in concentration of reactant per unit time. For product it is increase. Product बढ़ेगा ना बेटा, right? Melroy, are you getting it? Ryan, beta, are you getting it? Okay, so in general, if I want to define, then how I'll
Yes.
define rate of reaction is either decrease in concentration or increase in concentration of product per unit time. Clear? Okay. Which one? Where? That you don't see anything. I'll teach you that. Don't worry. Here it is given. Now pay attention here. What we are going to do, we have to study the unit of rate. Anvi beta, what will be the rate? Rate is what? We have studied now. ऊपर क्या आ रहा था? What was at the top? We used to write concentration, and below what we used to write time interval. So this square bracket means concentration. This below means what? Time, right? So if I take time up, so what I get, beta? Concentration time inverse. Are you getting it? Hey, Keegan, what will get? Concentration time inverse. Concentration is written as what, beta? Mole per liter. Or I can also write it as mole per dmq. Or I can also write it as molarity. Time means, or time will be always in seconds. So what all unit I can get here? Tell me. There you substitute this concentration here. So what do you get? Mole per liter per second. Or I can write it as mole per dm cube per second. Right, beta? Or molarity per second. Clear? This is for which reaction? Aqueous form. Which one? Aqueous. But beta, if it is gas, so in gases, do we take concentration or pressure? Pressure, na? So for gases, it will be instead of concentration, you will get pressure upon time. So what will be your unit? Pressure per time. Right, beta? Pressure either I can write in atmosphere or I can write in bar. But this will be in what? Second inverse. Right, na? So both the unit in exam, they will ask you this unit. Will you be able to write this unit? Look here. See, beta. Rate of reaction for solution and for gaseous reaction. Can you see? Hello, how you got this? Online students, I hope all of you are getting it. Yes, sir. Clear? Okay, right. Chalo, done. All of you. Right, chalo. Now, beta, we are going to go for next part. Okay. Yeah. Shobit, suppose, okay, you are coming from school to our class, and from school to class you are coming and you are telling me, sir, I came here at the speed of, let us say, 40 kilometers per hour. What he told me, beta, he told me that he came at the speed of how much? 40 kilometer per hour. Tell me, all of you tell me, beta, what will be his speed? His speed throughout the path, will it be 40 kilometers per hour, or sometimes it may be less, sometimes it will be more? Tell me. When you all come from your home, throughout the path, your speed is constant. Kya? Suppose there is a traffic, then your speed will be less. And when it is an open road, then your speed will be more. So basically, whatever he told me, he should have told me what? Sir, I came here at which speed? Average speed of 40 kilometers per hour. Right now? So when he say average means it is understood. Somewhere speed will be 20, somewhere it may be 60. So similarly, beta, whenever in speed we have like average speed, so we will have similarly for chemical reaction, we'll have what? Average rate of reaction. What, beta? Acha, when you all come from class to, from your home to our class, can you measure the time or not? Tell me. Obviously, no, beta. Because the time interval is very large, na? Right? Okay. So what is average rate of reaction? It is a rate of reaction which is measured over a large time interval. Large. And of course, when the distance between the 2 points is very high. Clear? So what is average rate of reaction? It is a rate of reaction which is measured over a large time interval. So for rate, what symbol we used to write? R, na? So for average rate of reaction, we'll write only this thing. That's it. That's it. Everything else will be one and the same. Nerissa, what was the formula for rate of reaction? We used to write this way, na? For reactant, it was minus delta A by delta T, right? Na? So for average, it will be what? Same thing. It will be same thing only. Minus delta A by delta T. But instead of this R, what word we are going to use? Average rate of reaction. What word we are going to use? Okay, chalo beta. Now what is this? Tell me. Hey, average rate of reaction. So what is average rate of reaction? Can you see instead of R, we have written R average. Hey, and here this delta T. This delta T is time interval. Time interval should be what? So define average rate of reaction. So what is average rate of reaction? Arush beta, it is nothing but rate of reaction only. अरे ये formula तो rate of reaction का ही था ना बेटा, right? So it is the rate of reaction only, which is measured over a large and measurable time interval. That's it. Is this clear? Okay. Now, suppose if you are coming from your home to class. Here, how much was the time interval? Can you see this time interval was large, na beta? यहाँ से you are coming here, right? So your time interval was very large or not? Tell me. Now, suppose, beta, when you are coming from your home to your class, if I tell you what was your speed at this particular point, what was your speed at this point, what was your speed at this point, so what was your speed at this particular time? Now, beta, do you know, beta, when if you go from vehicle, okay, they have some speed barriers. They have written this much should be your speed, but then if you cross that speed, you get a challan at a home with the picture of your car. So what they do, they are measure the speed at that particular point. They have fixed the cameras. Okay. So what we are doing, I'm measuring the speed at what? Suppose now, beta, I'm walking from here to here. If I'm going from here, listen, here to here, I have to. Oh, so this is large time interval or not? Tell me. But beta, if I tell you what is my speed at this point when I'm going to pass from this point, this particular. Can you see? So what was the time interval? Time interval was very, 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 very small or not? Tell me. So you are measuring, suppose you are coming from your class to it. What was your speed exactly at the gate of McDowell? This McDowell what? McDonald's. McDonald's. Okay. What was your speed exactly at the gate of that lucky sandwich? So what we are doing, beta, we are measuring the speed at each and every so at a particular instant, so that speed will be known as what? If I'm measuring, look from here to here, it is large and measurable. But here it is what? Very, very small. So your time interval will be very, 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 very small. Very, very small. We call it as dt. It is infinitesimally very, 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 very small. Maths pada hai? Maths mein you have done limit. Limit delta t tends to zero, but it is not zero. So the time interval is almost tending to zero, but it is so this, I'm measuring the speed at a particular instant. Therefore, that speed will be known as what? Instantaneous speed. It will be known as what? So what is the difference between average and instantaneous? In average, we measure over a large time interval. Here, we measure over a infinitesimally, very, 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 very small. Acha, now when you come, suppose from your home to class, so instantaneous, what I'll get the exact information at each and every point. What was your speed? So which speed we should prefer? Which speed give you the exact information, instantaneous or average? Exact information, exact information. Average? Instantaneous. So instantaneous is preferred over average. So now, look here. Define an instantaneous rate of reaction. So what is instantaneous rate of reaction? It is measured at a particular instant. Now look, beta. This was the normal graph which we did. This is reactant. Simran, beta, this is your Simran नहीं क्या नाम है तेरा मैं भूल जाता हूँ बार बार Zoya right Zoya beta hey this was reactant and this is what beta time तो अच्छा what will happen अरे concentration of reactant ना as time increases concentration of reactant decreases or not tell me and this is for product it is starting and then it is remaining constant अच्छा if this is your home, this is our class. So if you measure between these 2 points, then it will become what? Average. It will become what? But now if I want to find your speed exactly at this point, so this will be what? Instantaneous. All of you are math student. Acha, you have studied derivative, something called as derivative. The slope of the slope of a point on a curve. What is the formula for that? Slope of a point on a curve. Is it nothing but its derivative? It's nothing but its नहीं पढ़ा है तो कोई बात नहीं टेंशन मत लो अच्छा मैं तुमको बता देता हूँ हम लोग ऐसे भी कर सकते हैं कि नहीं बेटा वी विल ड्रॉ टेंजेंट टू दिस राइट ना हाउ टू फाइंड अ स्लोप ऑफ अ पॉइंट ऑन अ कर्व ड्रॉ अ टेंजेंट y2 minus y1 upon x2 minus Clear hai? So same way. So I want to find speed at this particular instant. Here also I want to find speed at this particular instant. So what I'll do, I'll draw a tangent and then find the slope. So in exam they may ask for 2 marks, how to find instantaneous rate of reaction. Then what you'll say, plot a graph of concentration of reactant or product versus time. Then at a particular instant, whatever a point on a curve, you'll draw a tangent to it and find its slope. Clear? And with the help of derivative, if you want to do the slope of a point on a curve is nothing but its derivative. So what is the derivative here? If I take a point here, so my time interval is very, very, very small. And here what I'm going to get, derivative of what, beta? Your reactant. So dA by dt. And for product we write, then you get dB by dt. Here it is coming negative. Why? Because graph is going downward. No? So it will be negative. But here it is positive. Why? For product is formed during the course of the reaction or not. Okay. Now here this dt is what, beta? Time interval is what, beta? Infinitesimally very, 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 very. So which rate is preferred over which rate? Why instantaneous is preferred over average? Because it gives you the information of each and every point. Now we go to the next part. Chalo. This is very important, and now there are a lot of numericals based on this. Very easy. Numericals. Okay, we are going to go for this part now. Differential rate expression. Differential. It is very, very easy. Now, tell me, beta. I'm going to write something here. A plus B gives me C and D. First, we'll write this, okay. If during the course of the reaction, what happens to reactant? Reactants will decrease or not? Product will? Very good. So, beta, if I want to write the rate expression for this, so for reactant, what I'll write? Change in concentration of A per unit time or not, tell me. So here I am going to write what, beta? Delta A or dA by dt. Are you getting it? But here what I'll write here? Minus. Now this is also reactant. So for this also what I'm going to write, please, whatever the number of reactant and number of product, between each number of reactant and product, you'll always put equal to sign. You'll always put. So how many reactant are here, beta? B. So this is reactant. So what will be the formula for rate? D delta B by delta T. Again, this is reactant, na? So during the course of reactant, what happens to reactant? It decreases, na? So what I'll write here? Plus or minus? Then again, you have to put equal to. Okay, for this product. So for product, what you are going to do? Tell me. Delta C by delta T. Again equal to delta T upon delta T. Are you getting it? Okay, for product, we don't write negative sign. Clear? Now, suppose if I have taken A moles of reactant and B moles of reactant and C moles of product, means any number to balance the equation. So what I'm going to do, whatever number we are going to use right here, we have to divide by that. We have to, because we always study for 1 mole. So here if it is A mole, for 1 mole it will be what? 1 divided by A, right na beta? So here how much I'll get? 1 by B. Here I'll get what? Here I'll get. During the course of reaction, what happens to reactant? They disappear or not? Tell me. So Nerissa, this is nothing but what? Rate of disappearance. What it is? Rate of disappearance. And what will be this? Products are formed or not? Tell me. So this is rate of appearance or rate of formation. Rate of. So during a common sense, in every reaction, the speed with which the reactant will disappear, with equal speed, the product will be formed or not. अरे जो रफ्तार से रिएक्टेंट कम होगा उसी रफ्तार से प्रोडक्ट बनेगा कि नहीं? टेल मी ड्यूरिंग द कोर्स ऑफ रिएक्शन. Now I'm going to apply this, and this expression is known as differential rate expression. This expression is known as what? So let us apply. Chalo, we'll start with me. Very easy. If I write this H2 plus Cl2, try to apply this differential rate expression for this. For balancing, I'm writing here 2. Now these are reactant and this is product. Always remember, reactant ke aage kya aayega? Shobhit beta, for reactant what you'll get? Minus. And for product what you'll get? Plus. Chalo, me ka R will be what? Tell me now. R is equal to, now this is what reactant. What we do, we write first concentration, beta. Do you know na beta? Delta we write. And concentration of whom, beta? H2 upon delta T. Delta or D, whatever you want to write, you can write. Will it be positive or negative? Acha, will I write any number here? Will I divide this? Why? Because there is only one. So then what you have to do again? Equal to. Then again what I'll get? Yeah, minus delta Cl2 by delta T. Okay. Then again what you are going to do? Equal to. Now what you are going to do? Delta or D, whatever you want to write. HCl upon dt. Is there any number before this? So what I'm going to write? Have you understood this? Now, China exam beta, what I'm going to do among these three, I'll give you value of any one, and then I'll tell you to find the value of remaining. Suppose beta, okay, Vyati beta, what is the relation? This is what your rate of, this is reactant, na? So rate of disappearance, and this is rate of formation. Acha, now suppose if I tell you, write the relation between rate of disappearance of chlorine and formation of HCl. So what you say? Rate of disappearance of chlorine is how many times? Half times the rate of formation of HCl or not? Acha. Anvi beta, if I tell you rate of formation of HCl is how many times the rate of disappearance of chlorine? So ये 2 को आप वहां पे लेके जाओगे कि नहीं? So it is twice the times of rate of disappearance of chlorine. Or it is twice the rate of disappearance of what? Hydrogen. Are you getting it? What I'm trying to say? Now suppose beta in this sum beta, if I give you value of this rate of hydrogen ka, ऐसे में I'm giving you the value of this is, let us say, I'll give you an example. Rate of disappearance of hydrogen is 2 into 10 raised to minus 2. ऐसा मैंने दे दिया. Then I'll tell you what is the rate of disappearance of chlorine then. Say what is the rate of formation of HCl then. No, this 2 will go here, no beta. And if I want to find this, then what will happen? This 2 will go here or not? So 2 into 10 raised to minus. So it will become how much? 4 into 10 raised. No, no. What I have said, rate of formation of, tell me, beta. I have given you value of this. So I'll take this. Delta H2 upon delta T. And on this side, whichever one I tell you, so these two will compare. So now what was written here? Tell me. I have given value of this. And in front of this, what was there? 1 by 2. And I wanted to find this part only. So this 2 will go here. And iska value is how much? 2. And this 2 will go. So it will become 4 times or not? Right? It is going to become double, na beta? Are you getting it? Chalo, next sum. What happened, Nerissa? Understood or not? Arush, beta, are you getting it or not? Tell me. Chalo, Arush, you are going to apply this now. Apply the rate law for the differential rate expression. R will be equal to what? ये reactant है तो what will come? Minus आएगा dn2 by मतलब delta n or dn2 whatever. Here again beta reactant है. So अच्छा, always put what? Equal to sign. Again it will come minus or not? First I write minus delta H2 by delta T. Any number is there here? So what I'm going to write? Okay, then again what I'm going to do? Equal to. Kick and don't look into phone. Look here. Delta NH3 upon delta T. And here I'll write half plus. Now what all question I can ask you? Chalo. Viyati beta, rate of formation of ammonia is how many times the rate of disappearance of hydrogen? Then this 2 will go here. So 2, नहीं, 2, हाँ, 2 by 3, yes. But minus बोलने का नहीं, because rate cannot be negative. Exam में what we will write, while writing the formula we'll write minus, but finally we'll remove that sign. A rate of disappearance of nitrogen is how many times the rate of formation of, rate of formation of ammonia is how many times the rate of disappearance of nitrogen. So this 2 will go here, it will become twice. Clear hai? Acha, if I say rate of disappearance of nitrogen is how many times the rate of formation of ammonia? Half. Are you getting it? दिमाग में गया सबके ऐसे बहुत सारे न्यूमेरिकल्स आएंगे. Hey, are you getting it or not? Easy na? Look beta, look, there is a rate of consumption or rate of disappearance. I have given this. Hello. क्लियर है? सबके बीच में इक्वल टू साइन है. बच्चे लोग गलती से यहाँ पे प्लस डाल देंगे. यू डोंट हैव टू पुट प्लस, इट हैज टू बी व्हाट? इक्वल टू. ये हैव रिकॉर्डेड और नॉट दिस? अरे तुम लोगों को बोला ना रिकॉर्ड. हाँ रिकॉर्डिंग. यार सो सॉरी. Hey, then I have applied this equation to this two. Now I'm going to do a numerical. Come on, you can do this orally also. Orally also. Hello, this HSC student, you look here. We started with this chemical kinetics. We did this, rate of reaction. Then I did beta what? Average rate of reaction. Then we did instantaneous rate. Can you see? This was reactant and this was product. Okay. Then I have done this differential rate expression. Can you see this? Now I want you to write an equation on your own for this. चलो. अरे सीबीएसई वाले सब लोग बोलो ओरली क्या होगा? या बोलो फटाफट नहीं आर बोलने का ना आर 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 इज इक्वल टू -1/2 डेल्टा या डी जो भी लिखने का है ओके इज इक्वल टू 1/4 डेल्टा अपॉन देन इज इक्वल टू हाँ बस डन इजी चलो वेरी गुड डन 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 चलो नाउ आई वांट यू टू या that was for 1 mark. Now the numerical which will come, that will come for 2 marks. Look, this is my numeric. काला की आ गया Hello. Chalo, this I want you to do on your own. Tell me what you are going to do. Look, whenever they gave equation and they were write disappearance, appearance means what? First they write an equation for this. What will be the equation for this? R is equal to minus the reactant and a minus half N2O5 upon then it will be 1/4. Got it, na beta? Then, then, okay. Now what they have given? So, Kigan, what they have given? N2O5 disappears at rate. So, whose disappearance they have given? मतलब खाली इसका वैल्यू दिया इसका खाली इसका ये हाफ नहीं आएगा उसमें ओनली N2O5 का वैल्यू इज गिवन सो बेसिकली व्हाट दे आर गिवन डेल्टा N2O5 अपॉन डेल्टा T इज हाउ मच 0.02 that's it clear now what all thing I have to find the rate at which NO2 and O2 are formed so first I have to find what is the value of O2 तो क्या करेगी बोल बेटा this you know अरे this value is how much बेटा 0.02 so what you will do come on 4 will go delta NO2 upon dt this 4 will go here so 4/2 into so it will become double basically so answer will be what 0.04 chalo if I want to find for this Shobit beta they have told now rate of formation of O2 also na beta so it will be what we know this value is how much 0.02 और इसके आगे कोई नंबर नहीं है तो it will be what half into 0.02 so it will be what 0.01 we'll never use minus हाँ बेटा because rate cannot be easy ना लास्ट पार्ट क्या बोला था बोलो तन्वी बेटा what is the last part they've asked रेट के लिए तो रेट मींस यू हैव टू कैलकुलेट आर सो यू हैव टू सेलेक्ट एनी वैल्यू तुमको कौन सा अच्छा लगता है ये वाला लेना है या ये वाला लेना है या ये वाला लेना है कोई भी एक ले लो आंसर तीनों का सेम ही होगा आर यू गेटिंग इट और नॉट अरे यार ना बेटा ऑल दिस इज इक्वल टू सबके बीच में क्या है आर के बीच में इक्वल टू है कि नहीं सो इट विल बी व्हाट हाफ इनटू 0.02 सो व्हाट विल बी द आंसर दैट्स इट इजी so rate of these are the sums which comes on rate of disappearance and appearance now this also you can do orally or not tell me अरे ये खाली इसके आगे क्या आएगा -1/3 अच्छा समझ और इसमें से किसी का वैल्यू लोग ने दिया है बेटा रेस्ट यू कैन कैलकुलेट यू हैव टू जस्ट कंपेयर इजी सो वी हैव डन रेट ओके और नो 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 यूनिट रेट का यूनिट विल बी ऑलवेज सेम ना बेटा ओके yeah so beta we have done this rate and all this numerical we have done now beta we are going to go for law of mass action have you heard about this word law of mass action or not loma yeah very good we have done in about 11th grade acha acha any reaction if I take before carrying reaction whenever we do first what we take reactants so rate of reaction will depend upon whom reactants right now if I take dilute HCl and zinc and concentrated HCl and zinc who will react faster constant so what is law of mass action now let me tell you but I notes please remember whenever I put this arrow means what this side is what reactant and this side is what product बच्चे क्या सोचते हैं कि अरे ये प्रोडक्ट है अरे नहीं क्योंकि अरे दिस इज रिएक्टेंट एंड दिस इज चाहिए तो लिख लो वहां पे ये रिएक्टेंट है और यहाँ पे प्रोडक्ट आने वाला दीज आर रिएक्टेंट्स ये तुम लोग ने वो इलेक्ट्रोकेमिस्ट्री किया कि नहीं किया? इलेक्ट्रोकेमिस्ट्री लास्ट क्लास आई रिवाइज्ड एंटायर चैप्टर फॉर यू ऑल. You have done sums also. I think you have missed two class. Yeah, but you are there, but all online. VAT has missed. But have you understood? I did all the numericals, everything. Have you solved the QB of electro? They are not given. चलो, ये ठंडी लग रही है तो एसी कम करूँ टेम्परेचर. ये फैन बंद कर दो. फैन बंद कर दे पहले. चल यहाँ से पहले ही वचन है एफ लिखा है वहां पे. हाँ. और एसी ये करना है तो वो भी कर सकती है बेटा. तो वो लेफ्ट हैंड साइड वाला है ना, 4 पे कर दे, 3 पे कर दे चाहिए. लेफ्ट हैंड साइड. हाँ. अरे एकदम करो. हाँ चलेगा. ओके. चलो. हेलो. Hey, this is my reactant. So my rate will depend upon whom given. Initially, what I'll take reactant only. So what is law of mass action? Rate of reaction is directly proportional to concentration of reactant. So rate I have written directly proportional. Who all are my reactant? A and B. So I written A, concentration, product of the molar concentration of the reactant. Am I using any number to balance them? So raised to their stoichiometric coefficient. This was what your law of mass action. But we are not interested in law of mass action here. Okay. We are interested in something else. Clear? This is, I'm just introducing what is law of mass action. Okay. Whenever I remove this proportionality, I write equal to K. But we are interested in what? Rate law. We are interested in what? Now look here. A, I have written A again. Please, this is not product. Huh? Product is on this side. This side is what? These are reactants. We have applied Loma. So for Loma, what I'll get? R is equal to K, A raised to N, B raised to. But suddenly from experimental study, oh my God, what happened? Instead of A, क्या हो गया? Instead of B, क्या हो गया? Achha, now what I want to tell you this. If I'm carrying out any reaction in a vessel, is it necessary that both entire reactant will get converted into product? No, no. Suppose ये दो ढक्कन ही जा रहा है इसमें से. ये दो ढक्कन का ही प्रोडक्ट बन रहा है. Are you getting it? But that this you'll come to know when, beta, when you perform the experiment in the lab. But if I just write a reaction on the board, can you tell me all the reactants are getting converted into product? What do you think? These two reactants are there and these two products are forming. So similarly, beta, if I'm carrying out any reaction, suppose this was my A plus B, and it is forming some product. It is forming some. Achha, initially, let us say I have taken how many moles of A? 1 mole. And this is also 1 mole before the reaction. Before the 1 mole, 1 mole. But finally, what I get, finally, this is very important. इसमें से कितना चला गया? Let us say how many moles went? 0.5 moles went. So how much is remaining only? And here let us say 0.2 moles are going. So how much it will remain? Let us say point. So acha, this you came to know when you do the experiment in the lab. Then only you can weigh how much reactant left, how much product form. So basically from this how much went? How much went? 0.5. And how much went from this? So initially, how much I taken? 1, 1. But finally, how many went from this? But how many reacted? So this is the moles which has reacted. This is the moles which has reacted. Are you getting it? So initially, how many moles I took while balancing? A moles. B. What happened? अरे बाबा वो कुछ भी लिख सकते हैं. मैंने ऐसे लिखा. ए ले भाई. A, B. This was initially 1, 1. Now let us say from this how much went? 0.5 went. And from this how much went? 0.2 went. So this was your initial, this was your initial, how much, and this is your X, and let us say this is your Y. Push. Yeah, it can be. And it is not necessary. Both the moles can react also. Yeah, yeah. No, no, no. We have written differently because two different reactant, na? That is why. Two different reactant, na? So initially how many moles was there? So this is was basically what beta? This was my initial mole. Initial mole was how much? A. This was how much we have taken. Can you see? B. But how many reacted from A? X reacted, na beta? So this is now suddenly instead of A, what I have written? Here suddenly instead of B, how much reacted? So this will, but this will get only by which study? Which study? Experimental study. Strictly from which study? Experimental study. Clear. So what experimental study? It will give you exactly how many reactant moles of reactant has reacted. Clear. So this is known as rate law. This is known as, look, I have written here also. A, out of A moles, how many reacted? X. Can you see out of A moles of A, only X moles react. And out of B moles of B, how many reacts? So what is this rate law? Rate law also give you relation between concentration of the product of the reactant only. Right now, raised to the which coefficient, not their stoichiometric coefficient, raised to the coefficient which has been derived by which study? Experimental study. That is very, very important. Clear? Right, beta? Okay. If whenever we remove proportionality constant, we write what is equal to K. If we are studying this for rate of reaction, so we'll call this as which constant? Rate constant. A rate constant is also known as specific rate. They have given different name for it. It is also known as specific. It is also known as velocity constant. It is also known as. So now look, beta. This is very important. Rate law. Can you see rate law का definition क्या है? This word is very important. Experimentally expresses the rate of reaction in terms of the molar concentration of reactant, not predicted from the stoichiometric coefficient of the reaction, not from the stoichiometric, but from which study? Experiment. Chalo, henceforth in this chapter, beta, we are not going to apply Loma. We are going to apply what? Rate law. Keegan, beta, again, this is not product. This is what? Yeah. Reactants. These are what? Acha, now I am directly applying rate law. So will A or B will come or X or Y will come? X. Hey, beta, let me tell you, कभी कभी X can be equal to A. अरे पूरा reactant अगर खत्म हो रहा था, it can be equal to B also, beta, right? Hey, I got this. Zoya beta, if I take concentration of all the reactant as one, all the reactant as, so what will happen beta? ये पूरे का वैल्यू कितना हो जाएगा? 1 हो जाएगा. तो what will get? R is equal to K ना? R is equal to what? ए शोभित बेटा, if I take all reactant, अरे यार ये देख, ये पूरा ये क्या लिया? This is also 1, this is also 1, this is also 1. So what I'll get? R is equal to K or not? अच्छा, so we want to define what K. What was the name of K? Please write this, बेटा ऐसा स्लैश करके लिखो. Rate constant is known as velocity constant. It is also known as specific rate. Done, done. Okay. Okay. Hey, Shobit beta, we took this 1 1 na. So my K is equal to rate or not? Tell me. Yes. And this K was what my rate constant. ऐसा सिंबल तो लिखा नहीं हम लोग ने K. Okay, सिंबल भी लिख दो ना ऐसा K. All this का सिंबल क्या है? K. Hey, so my velocity constant or rate constant is nothing but rate of reaction. R was what? Rate of reaction. So rate constant is nothing but rate of reaction when concentration of all the reactant is taken as unity. बराबर है. डेफिनेशन मिल गया. अरे बोलो ना. Avni beta, are you getting it or not? Tell me. So look, rate constant is nothing but the rate of the when the concentration of all the reactant is taken as unity. Now this chapter ka very important part we are going to do, that is what? Molecularity and order of reaction. Molecularity and order. Okay. Pay attention here. In school you used to get project or not? स्कूल में कुछ प्रोजेक्ट मिलता है कि नहीं? ग्रुप प्रोजेक्ट एंड ऑल, राइट? Suppose there is one project. Okay, there is one project, right? Me and Vyati are participating in that project. By the way, she's Vyati. Okay, she's Nerissa, is Jiaul Haq, and then so yeah, Tanvi and Arushi. She's Jiaul Haq. Anyway, okay, me and Vyati are there in project. How many person are participating total? Two of us. Okay. This project is happening. Vyati is doing work on the project. I'm not working on the project. And by luck, this project got first prize. So in school, the comparer will come and they will announce name of both of us or not. Tell me. And as an audience, you are clapping also. Wow, right? So as an audience, what do you think that both of us have worked on the project? But actually, did both of us work on the project? I was not working only, na? Only she was working. So how many persons were working on the project? So look, if as an audience you want to know who has worked on the project and who has not worked on the project, what you will do? We'll do one experiment. What experiment you will do? You will ask question related to the. She will answer fatafat. But if you ask me, but this when you came to know that who is working only after doing one experiment or not? Tell me, right? So now listen carefully. Hey, listen. If I write any reaction on the board, suppose I'm writing two reactant and product. So as directly, if you see the reactant, what you will come to know that how many reactant are participating. But to know actually on which reactant the speed is depending, for that what you'll have to do? Experiment. So what is molecularity? Listen, beta. Hey, this example, if you'll keep in mind, you'll remember. Shobhit, beta, what is molecularity? It is nothing but number of people participating in project. But we are studying with respect to what chemical reaction. So what you will say? It is the number of reactant taking part in the reaction. It is the number of reactant taking. If I write any reaction on the board, you can tell me what is the molecularity. And you will see how many reactant I have written. Clear? So it is which concept? Theoretical concept. Molecularity is what, beta? Theoretical. Acha, and what is order? Order is nothing but it is the reactant on which the speed of reaction or the rate of reaction will depend. Means who are actually working on the in the reaction. Acha, if I want to determine, I gave you this first example. Me and Vyati are participating. So what was the molecularity? 2. But who was working in the project? Only Vyati was working. So number of person working in the reaction. That is nothing but order of reaction. That is nothing but. So what will be the order of reaction only? How many people were participating? Acha, but order I can find order only when you did what? So order is which concept? Acha, now listen, beta. Hey, suno. Zoya and Vyati both are there in the project. So how many people are there in the project? Both are working also. So acha, how many of them are participating? So molecular days. Acha, both of them are working also. So speed is also depending upon both. So what will be the order? Are you getting it? Yeah, molecular is theoretical ना बेटा. हाँ, ऑर्डर इज एक्सपेरिमेंटल बिकॉज अच्छा हाँ, हम लोग ने प्रोजेक्ट में पार्टिसिपेट किया सपोज तूने और ये नहरीसा ने पार्टिसिपेट किया प्रोजेक्ट में नहरीसा इज वर्किंग एंड यू आर नॉट वर्किंग एंड वी ऑल आर ऑडियंस okay and suppose your project got the first prize then I'll announce both of your names na and as an audience will think अरे दोनों जन ने कहा so that is number of people participating in the project is nothing but molecularity but if I want to know who has worked then I'll ask question to both of you she will answer but he will not answer as usual okay right anyways okay so I did one experiment na? So similarly, suppose if I have written any reaction on the board, just by looking at it, you can tell me now what is the molecularity. But will you be able to tell me what will be the order? No. For that, you have to go in the lab and do one experiment. Okay, case 2. Zoya and Vyati both are participating. How many people are participating? Both of them are working also. So participating. So molecularity is what? And order will be also understood, clear, okay, right? Chalo beta. Tanvi and Mihika both are participating. So how much is the molecularity? Tanvi is doing 100% work and Mihika is doing only 50% work. So then what will be the order? Tanvi is working entirely and Mihika is working only half. So 1.5, 1.5. Right now, beta? Are she is working pura and you are putting only half effort. So what will be the order? 1.5 or not? Tell me. Okay, last case. Shobit and Keegan, both of them are in the project. So how many of them are working? Oh, sorry, participating? 2. How many of them are participating? 2. अब दोनों जन बोलते अरे यार हम करेगा प्रोजेक्ट एंजॉय करते लाइफ में सो दे आर एंजॉयिंग बट यू नो ना बेटा स्कूल में प्रोजेक्ट तो सबमिट करना है वी वांट टू सबमिट द प्रोजेक्ट देन ओनली विल गेट द मार्क्स सो दे अप्रोच थर्ड पार्टी, दे अप्रोच टू आरुष। बोला अरे आरुष हमारा प्रोजेक्ट बना के दे देना यार, जो बनता है तेरे को दे देंगे। ओके ठीक है ना। सो अच्छा नाउ टेल मी, ए हाउ मेनी ऑफ देम आर पार्टिसिपेटिंग? But so molecular is how much? Are they both working? So what will be the order? Okay. But they are completing the project, na? And who completed the project? They completed all the external factors. हाँ, बहुत टाइम पे रिएक्शन में ना एक्सटर्नल फैक्टर होता है, कैटलिस्ट, प्रमोटर, टेम्परेचर, प्रेशर। अच्छा, इन दिस एंटायर थिंग, डिड यू नोटिस in first case both me and Viyati were there, so how much was the molecularity? 2, and Viyati was working, so order was, in all these cases, you see, molecularity was always whole number. But when Tanvi and Mihika was there, what was my order? 1.5. When Shobit and Keegan were there, then what was the order? The order can be what? Whole number also. It can be zero also, and it can be fraction. Can molecularity be zero? Hey, molecularity है ही नहीं, मतलब reactant ही नहीं है, तो reaction होगा क्या? अच्छा, लुक बेटा, यू इन 11th स्टैंडर्ड वी हैव डन लॉट ऑफ बैलेंस इक्वेशन। कहां पे भी आपने फ्रैक्शन देखा था क्या बैलेंस्ड इक्वेशन में? बैलेंस इक्वेशन में फ्रैक्शन कभी नहीं आता है। अगर फ्रैक्शन आता तो वी यूज्ड टू मल्टीप्लाई, डू यू रिमेंबर? ओके, दैट फ्रैक्शन वी गॉट फॉर 1 मोल। हाँ यार। ओके नाउ लुक यार, पहला भी दिमाग में ये कॉन्सेप्ट समझा क्या? लुक बेटा, इन टेक्स्ट बुक इफ यू रीड ना बेटा, मॉलिक्युलरिटी दे हैव गिव एक्सप्लेन ऑर्डर फर्स्ट एंड देन दे हैव एक्सप्लेन molecule. So whenever you do order and molecularity, what example you will remember? Project example. What example you remember? Project. And beta molecularity and order of reaction. Molecularity and order of reaction. Okay, molecularity was what? Number of participant. Na? So we'll say number of reactant taking part. Don't write, everything is given. Number of reactant participating. Here, number of reactant which determines, hello, speed of reaction. It was which concept? Theoretical. This was a molecularity can be sorry, can never zero nor fraction, never zero nor fraction, never zero nor fraction. चलो ठीक है ना बेटा? This can be what? Zero also, and a molecularity, what will molecularity depend on external factor? No. A last example we did, Shobit and Keegan were participating. Okay, but both of them are not working. So who completed their project? Arush. So they are depending upon external factor. So ये external factor पे depend करता नहीं है. But this will depend on. Now you come to this part. चलो आ जाओ. No, yeah, order will be zero because we always deal with the reactant first. Okay. Now look here. I have written here molecularity first. A molecularity means, or suppose this if I write any balanced chemical equation, whatever number is there, if you add them, you will get the molecularity or not. Tell me. It is the number of reactant taking part. It is the sum of the stoichiometric coefficient. It is which quantity? Theoretical. It is independent of. It is non-integral number. Non-integral means never be zero nor fraction. अच्छा, I have written this balanced equation here. चलो जोया बेटा, हमने रिएक्टेंट आर हियर 1 and 1, तो टोटल कितना हो गया? 2. सो मॉलिक्युलरिटी इज 2. मी का बेटा, हमने रिएक्टेंट हियर, सो मॉलिक्युलरिटी विल बी 1 यूनिमॉलिक्युलर. So are you getting it or not? Tell me. Any balance equation you just see the number of molecules on the reactant side, that is nothing but your molecularity. But can you, just by looking at this, can you tell me the order? Never. Because for order, you have to do experiment in the lab. You'll have to do, yeah, you'll have to do experiment. Okay. Arush beta, how much is reactant here? 2 and 1. So what is your molecularity? Right? अच्छा, now order. A order में suddenly क्या हो गया बेटा? A, Arush beta, here it was A and A, but suddenly here it has become what? X and Y. क्यों? X and Y कहाँ से आया? Experiment. Experimental study. Clear है? It is the number of reactant molecules determining the rate. अरे मॉलिक्युलरिटी में क्या होता था? पार्टिसिपेंट होता था. यहाँ पे तो क्या होगा? जो काम करने वाला है प्रोजेक्ट पे, राइट? इट इज बेस्ड ऑन विच कॉन्सेप्ट? इट डिपेंड्स ऑन. क्लियर? सो इन दिस एंटायर चैप्टर बेटा, molecularity will never have to by heart. Any reaction if I'll give you, you can directly write the molecularity. But what we'll have to by heart? Order by heart करना पड़े. क्योंकि वो एक्सपेरिमेंट से आता है ना. ए order can be zero, can be fraction, can be. So few example I have given here, beta. Look, hey Nerissa, look here. This is phosphine. Hey baby, look here. How many reactant are here? Balancing के लिए what I have used? Two. So molecularity is two. Whatever number I use for balancing, that is your molecularity. But order is how much, beta? Zero. There was no logic for this. That is from experiment. So now by heart, so we have to by heart. But when I do experiment in lab, then only I'll come to know, na. But I'll just tell you, beta, look here, what I have used here, catalyst, so external factor. Therefore, the order was what? Zero. Are you getting it? I've just given one simple example for it. In exam, beta, they have asked many times, distinguish between molecularity and order. देखो molecularity and order का distinguish अभी बताया कि नहीं. अच्छा, ये समझने के लिए आप क्या what will remember if you want to remember this? बोलो. हाँ, project example. Clear. प्रणीत, मेलरॉय, और कौन है भाई?
हाँ सर क्लियर.
Ryan, beta, are you getting it? Mirinda, are you there or sleeping or what?
Yes, sir. Getting.
Yes, sir.
Yeah. Done. Hello. चलो. क्या है? What do you want? Yeah. Now look, beta. Two reactants are there and it is giving. This arrow का मतलब they are forming product. They are not product. Okay? Me का beta, look here. I have written this. This is in large. Excess. Large or excess. Okay. Acha, now tell me, beta, rate will be what, beta? Rate would have been what? R is equal to K. It should have been dependent upon both the reactant or not, tell me. But beta, this is written what, beta? Excess. ठीक है ना? अभी आ जाते हैं. Hey, we are going for a picnic, huh? I mean now only. Okay. So we have gone to picnic and we are in one resort. Nice. We are enjoying in the resort. Okay. In the resort, there is a big swimming pool. Oh my God. Okay. And this swimming pool is filled with water. And then there is a glass next to the swimming pool. In this also I have filled what? Water. Okay. We are must enjoying in the pool and we are sipping the glass of water and everything we are enjoying, and then now again everything is set, and in the meanwhile we go for what for lunch. Okay, during that time one fellow comes and what he does, he removes one bucket of water from this swimming pool and he removes little bit of water from this glass and he vanishes. Then again we come. Then we look at the swimming pool and we look at the glass of water. Now you tell me where you will see the difference in water level. Why not in swimming pool? Because it was in large excess. So imagine if there are two reactants. If there are two reactants, one of them is in what? Excess. So if in excess there is little change, that change is not visible. So it practically remains constant. But here you will see the difference in water level or not? Tell me. So now tell me here, then my rate should have been dependent on both this. But tell me, beta, this was your swimming pool. Excess वाला तुम्हारा क्या है? Tell me. Swimming pool. And this is what your glass. So now what will happen? This K is constant or not? Tell me. Harush, beta, this K is constant. And this is also what? Constant. So constant into constant, what I'll get? New constant or not? But why this excess became constant? Because it was in. So what I'll get? K dash. What is now your this K dash? K dash is nothing but K into Y. Right now, beta? So now how many reactant we got? Only. Now tell me now my rate of reaction is depending upon only how many reactant? Yeah, it is depending upon only how it is depending upon how many reactant, only one reactant, only how many beta. Look here, my actual rate of reaction should be of higher order or not. It should have depended upon how many reactant, two. But now it is depending only upon the rate of reaction which appears to be higher order but behaves as what? Lower order. उसको हम लोग क्या कहते हैं? Pseudo. Pseudo means false. False first order reaction. Pseudo first order. How will you come to know that the given reaction is pseudo first order reaction? They will always give you how many reactant? Two reactant. They will always give you how many reactant? Two. And below one of the reactant, they will write what? Large or excess. Large or. So in order to understand this concept, what example you will remember for pseudo first order? Tell me. Tell me, beta. This is very, very important. Huh? They ask this very frequently. So what you'll remember this? Swimming pool and glass of water. ठीक है? Okay. A. Look, Tanvi beta, two reactant was there. One was excess, so rate should have been dependent on both. But this K into excess become a new constant, right? Certain reactions which were expected to be what? Higher order. But follow. एक ही reactant आया कि नहीं यहाँ पर? Follow first order. They are known as which reaction? Pseudo first order. In your entire syllabus, we have only two examples. Only. So you'll have to buy out these two. Which are these two examples? Zia beta, how many reactant are here? Tell me. Two. And what is this inversion of cane sugar? This is cane sugar. It gives you glucose and fructose. A. Out of this, who is excess? So earlier my rate should have been dependent on both or not, tell me. But this is K. ये K है, दिख रहा है कि नहीं K बराबर? K and this is water. K is constant and excess will be what? Constant. So K into water will become constant. So what I'll get? Finally my rate is depending only on one reactant or not. So it is pseudo first order. Chalo, and last one. Acid hydrolysis of ester. Acid hydrolysis of. Okay, now tell me, beta, this is ethyl acetate, this is water. How many reactant were there? Vyati beta, two reactant. But below one, what they have written? Excess. This is also K. Is this visible or not there? See. So K into this water. Nerissa, this K into water, it will become new constant or not? Tell me. So earlier my rate of reaction should have depended on how many reactant? Two. But actually it is depending now only on. Therefore, it is following first order, but it is which first order? Pseudo first order. So what are pseudo first order reaction? Reaction which were expected to be a higher order, but follow first order. There are pseudo first order reaction. Achha, in MCQ, what type of question they can ask? Apart from these two, what they will do? They will give you this way. X plus Y gives product. And below one of the reactant, they have written what? Excess. And they will tell you, tell me it follow which order? Does it follow first order or second order or pseudo first order? What will be your answer? Are you getting it? This type of question will come. So what will be your answer? It follows which order? Pseudo first. Any difficulty till here? Tell me. Okay. So what all thing we did today? Come on. Look here, hey, girls here. यहाँ पे देखो मैंने यहाँ पे क्या कराया तुम लोगों को देखो यहाँ पे this rate law. If we did look in textbook they have given order, but you will not understand anything if you read from this textbook. You remember that example and then you remember beta. Look, A, can you see this order here? A, tell me what was the molecularity here? 1. But what is my order? Order can be fraction also. It has got nothing. Here what will be your molecularity? Tell me. 1 and 1. Molecularity should have been what? 2. But what is the order here? समझ में आ रहा है कि नहीं बेटा? हाँ तो मतलब zero order with respect to CO2, but with NO2 it is what order? Second order. So order will have to by heart. Yeah, and not necessary. Yeah, some external factor, because here we have not shown. It can be pressure, temperature, or catalyst. I'll give you the list of order which we have to by heart. Then beta, we did molecularity. Can you see this molecularity? If suppose beta, if it is only one step reaction, if it is only what, then order and molecularity will be same. What is one step reaction? We call them as elementary reaction. Which reaction? Acha. Okay. And data is distinguished. But first beta, you should know molecularity and then order. This is I I'll give you beta. Okay, I'll give you. Don't worry. पहला आज खाली concept मैंने I have introduced. We are going to study in detail in next class. But till here, have you understood this? Perfectly understood. Molecularity order concept. Okay. Right. So till acha. Then what I did, one more thing I did for you. What I did, textbook में sequence is given a very heavy. I follow my notes. We did which order? The pseudo certain reaction which were expected to be what? Higher order. But they follow which order? Only two example. Acid hydrolysis of ester. And second one is which one? Acha, now tell me beta. This is what? Directly you can tell me this is cane sugar, huh, beta? Acha. Will it be pseudo first order? You have to look at the two reactant. And what is written here? Below one of the reactant, if it is written excess, then it is always going to be what? So can it be pseudo first order? Yes. Understood. Now look, beta, can you see this example of zero order they are given? Look. अच्छा, what would have been the molecularity? शोभित बेटा कितना reactant है यहाँ पर? तो molecularity is 2. वो देख के पता चलेगा, but आप order देख के बता पाओगे? It is a zero order. Because here we use catalyst, हाँ बेटा, ठीक है? This is also zero order. Zia, बेटा ये देख, ये क्या है? How much is the molecularity? But it is which order? Phosphine also. It is which order? Because look, external factor, high temperature and pressure. So this example you'll have to buy. I'll make a list of zero order and first order, which you are supposed to buy at. That I'll give it to you all. Any difficulty till here? Perfectly understood. So look, acha, next class beta again I'm telling you what all thing I'm going to do. We are going to do derivation of zero order and first order and numericals. बहुत easy chapter है बेटा. कितना easy था ना? पक्का? Okay. That's all for today. Hey, this Xavier students, you are going to come on Monday, huh?
So 4
Hello,
o'clock, right?
Ryan, Melroy,
4, right?
your timing. I have made a separate group for you. I'll update the timing. 4:15 p.m. You have to come. 4:15.
Okay, sir.
Okay.
Yes.
Bye bye. Hey, wait. Simran. Arey yaar, Simran.